Now we can define thermal conductivity. Rate of heat transfer through a unit thickness of the material per unit area per unit temperature difference. So the thermal conductivity of a material is nothing but the ability of a material to conduct heat. Higher the value of thermal conductivity, it indicates that it is a good conductor of heat, and lower the value of K, it will indicate that it is a poor conductor of heat. So I'll show you some examples, some values. The thermal conductivities of some materials at room temperature, you can see diamond 2300 watt per meter degree centigrade, whereas urethane or rigid foam is 0.026. So you can say that wood, helium, soft rubber, right, human skin, they all are bad conductor of heat, whereas silver, copper, gold, aluminium, iron, mercury, they all are good conductor of heat. You can see the range of thermal conductivity of various materials at room temperature. We'll start with the non-metallic crystals, graphite, diamond, highest thermal conductivity. Then comes pure metal, silver, copper, iron and manganese. And then metal alloys, aluminum alloys, then bronze, steel, nichrome. You'll always see that thermal conductivity of alloys of pure metal are always less than the pure metal. I'll show you some examples of it in the further slide. Non-metallic solids, oxides will have less thermal conductivity, rock, food, rubber. Then comes liquid, mercury, water, oil. Then come insulators. You can see the range. You can see the range over here between 1 watt per meter Kelvin to 0.01 watt per meter Kelvin. So insulators, and then gases, hydrogen, helium, air, carbon dioxide, they all are bad conductors of heat. As I said, always alloys will have lower thermal conductivity. So here in the table you can see pure metal or alloy, copper is having 401 watt per meter Kelvin of thermal conductivity, nickel is having 91 watt per meter Kelvin at 300 degree K, but its alloy constantan, which is having 55% of copper and 45% of nickel, is having thermal conductivity of 23 watt per meter Kelvin. Again, copper and aluminium alloy, which is commercial bronze consists of 90% of copper and 10% of aluminium, but see the thermal conductivity, it's only 52 watt per meter Kelvin. Pure crystals and metals, they will have highest thermal conductivities, and gases and insulating material will have the lowest thermal conductivity. You can see here thermal conductivity do change with temperature. So here I have listed down the table: 100K, 200K, 300K, 400K, 600K and 800K. So thermal conductivity of two metals I have listed like copper and aluminium. You can see that as the temperature increases, the thermal conductivity of metal decreases. Thermal conductivity of metal decreases. So here, as discussed earlier, air also acts as a bad conductor of heat, but you can see here in the graph, as the temperature increases, its thermal conductivity increases. Same is the case for steam, same is the case for argon. As the temperature increases, their thermal conductivity increases. But for rest of the say metal, silver, copper, gold, aluminium, right, their thermal conductivity decreases with the increase in the temperature.